So let's look at example 4. Let's consider a signal that is the summation of two real exponential. Okay, so we have a signal xn equivalent to given by this equation. So the first question is that determine the Z transform. Second one is that sketch the region of convergence ROC for signal xn. So what you can do is that you can use the matching with the Z transform table. Okay, so I give you these two different table. Normally I'm going to refer to this table because it actually represent the formula, the equation that I'm going to derive. So you can actually use two different tables. So I will upload this the two different table also in Ulen. So this table can be referred, or the following table is actually the same one. Okay, just that if you see here how the Z transform equation is write out is different. Okay, first one is that Z over Z minus A. So this one is actually how to get this is just divide by Z over Z. So you get 1 over 1 minus alpha Z minus n minus 1. Okay, so it's actually the same equation, right? So first let's go see how to actually determine the Z transform. So what you need to do is simple. Okay, you see that there are two equations here. First one and second one is this equation. Okay, first equation, second equation. So what you need to do is that by referring to the Z transform table directly. So look at this equation. Okay, we have 7 in bracket 1 over 3 and un. So imagine that 1 over 3 is actually alpha. Okay, refer to this and match it with this table. So it actually represent alpha to the power of n un, right? This one. Okay, so you have the matching, which is the Z transform is given by 1 over 1 minus alpha Z minus 1. So the reason why when you write out, you will write it as this. So you have 7 1 over alpha is 1 over 3 in the Z bracket minus, so you are going to do the second one. So this one is alpha, so 6 1 minus alpha is 1 over 2 Z minus 1. So actually if you match it, okay, you will get alpha n un. Okay, the matching with the Z transform is given by 1 over 1 minus alpha Z minus 1. Okay, so this one is where you write this equation. Okay, of course for the amplitude here you just take it out, so you have 7 here and minus 6 over here. Okay, so after that just rearrange it, then you will get 7Z. Okay, Z minus 1 over 3 minus 6Z Z minus 1 over 3. So this is how I get this, is that actually by multiplying by Z over Z. Okay, so to get Z value, so 7Z over Z minus 1 over 3. Okay, rearrange it, you get this step. Okay, next is that you arrange again until you get the final step here. So to get to this step is that you need to expand it and then rearrange it again. So you will get the final equation is given by Z multiplied by Z minus 3 over 2 over Z minus 1 over 3, Z minus 1 over 3. Okay, so you can either left it in this form or in this form. Either one is the same. This is referring to the equation just now. So either you left it with Z value, Z over Z minus A alpha, or 1 over 1 minus alpha Z. So if I'm going to refer to the same equation here, so I'm going to actually divide it by Z over Z here, then rearrange it, I will get this final equation. So I get the final equation. So just divide by Z over Z. Okay, so this is how you find the Z transform. Second one is that sketch the region of convergence for signal xn. So just now you find the exact value for this equation. Okay, so you found out that you have this equation 1 minus 1 over 3 z minus 1. Okay, so it can be either this one or this one, right? But wait, but refer back to your original equation. Original equation just now was alpha n un, so which is this one. So the region you need to take is z more than 1 or z more than alpha. Okay, so for the first one here is the ROC is z more than 1 over 3, and the second ROC is z is more than 1 over 2. So it means that okay, sketch the ROC. So you have 1 over 3 is here. You have the unit circle 1, I already draw it. So 1 over 2 is here. Okay, 1 over 2, the ROC is this side. Okay, so I'm going to sketch it. Okay, 1 over 2, more than 1 over 2. Okay, for 1 over 3, I'm going to sketch it in the different direction, like this. Just to look at. Okay, for both ROC just now, this one and this one, okay, which area where both are overlapping? Okay, area which is both overlapping is actually for this z more than 1 over 2, right? Because for z more than 1 over 3 is actually overlapping with the z of more than 1 over 2. So meaning that the final answer for the region of convergence for signal xn here is actually z more than 1 over 2. Okay, based on the two area that it's overlapping. Okay, so answer is z more than 1 over 2. Okay, so this one is just the property of the ROC, so you can just read it. So ROC is a ring shape centered at the origin, then the ratio is from minus to minus infinity and so on. Okay, if you have a right-sided sequence, the ROC extend upwards. So this one I already summarized that. And if you have a left-sided sequence, the ROC extend forward, inward. And for the two-sided sequence is that it consists of the ring type, which is bounded by the interior and exterior of the two poles. Okay, and ROC must be a connected region, means that if you see here just now, that means that there must be an overlapping area, or connected means that convergence of the area. Okay, so we go to the next section, which is the inverse Z transform. So there are two methods for the inverse Z transform. First one is method 1 is by inspection. So what you did in the previous example 4 was by inspection, means that directly you look at the signal given xn, you inspect it, you check the the Z transform table, then you can directly get the Z transform equation of that signal. Okay, that is what it means by inspection. Method 2 is that by doing partial fraction. So what you do, you need to do partial fraction. Partial fraction happen when you have a complex equation, means that it's not similar to what you see in the Z transform table. So you need to do a partial fraction first to actually organize it to become the format that you can refer to the Z transform table. Okay, so yeah, like by inspection is that the similarity of the form that we can recognize based on the table, so it is limited by table. So this is what you did just now lah. So you look at it, you see that you have the in the format a n u n, so you directly do a table, you can use this equation. This is what it means. Okay, and for the inverse transform, so if you are given this signal, so directly by inspection to the Fourier transform table, you can directly get the answer is xn equal to 1 over n un. So because for the Z transform is that for this one is, you know that you have alpha n un. Okay, So alpha is what? 1 over 2. So 1 over 2 and un. So this is what it means by matching with the table. Partial fraction, the method 2 is that when you do not have the form given in the table, so you need to actually resort to another technique, which is partial fraction. You actually make it a simpler equation, so that you can actually use the matching method by inspection in method 1. So let's look at this example 5, which is, if you see here, is that you are given the x, z is given by 3 minus 5 over 6 z minus 1 over 1 over 4 inverse z, and so on. Okay, and you see that you can actually match it with the table. Okay, so what you need to do is that first, if you see the question is that determine the stability of the ROC, so it means that this means that find the ROC. Okay, second one is that obtain the partial fraction, so this one is given a hint now, so to get the answer, so find the partial fraction first. Okay, so similar to what you did in the Fourier transform, Fourier transform. And lastly is that after you get the partial fraction, then find the inverse transform to get the signal x and value. Okay, and then it says here that sketch the region of convergence for the following when you have z more than 1 over 3, z less than 1 over 4, and z between 1 over 4 to 1 over 3. So let's see the first one, determine the stability of the function. So for this case is that you can directly look at the numerator over here underneath here. So you have 1 over 1 over 4 z inverse z, 1 minus 1 over 3 z inverse z. So if you refer to the matching type, matching here, so you can actually see that it's given by, the equation might be either this one or this one. Okay, if you were to write it for the first one, RC is z more than 1 over 4, right? And then second one is you have z more than 1 over 3. Okay, assume it's like this, but like I said, for stability is that when you have the region of convergence, it's actually overlapping between these two equation. So you have 1 over 4 here, you have 1 over 3 here. If you were to draw it, the circle 1 over 4 and 1 over 3, okay, which one is it more than, is less than or more than 1 over 4, where, or 1 over 3, where it's actually going to overlap the area. So if you were to actually sketch this, 1 over 3 here, okay, another one is 1 over 4. Means that what happens is that I'm sketching it for both z more than 1 over 4, right? And z is more than 1 over 3. So it means that the overlapping area here is actually at z is more than 1 over 3. So the stability is for the ROC is z more than 1 over 3. So this is the answer. Okay, so determine the stability. Okay, answer is z more than 1 over 3. Second one, okay, second question is that obtain the partial fraction of the z transform xz. So you have the equation at z equal to 3 minus blah 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 and so on, where you already know that the ROC is z more than 1 over 3. Okay, so partial fraction, like what you have learned in the Fourier transform. Okay, so we do the partial fraction, divide this because you have the numerator down here, 2 numerator. So you have a over 1 minus 1 over 4 inverse z plus b 1 over minus 1 over 3 z minus 1. So you are going to find out what is the value for a and b. Okay, so using partial fraction, find a, so a 3 minus 5 over 6 z blah blah blah. Okay, substitute it. You can try to do this at home, even though I'm giving you the answer, but you need to try and do it at home, because later on when you submit for final exam, if you give this type of answer, then I know you are copying from your friend. Okay, And bear in mind, the question is not the same with other student. So it's different student get different question. So please write properly, write completely the answer. If you skip the answer, then you get only 1 mark lah for the final answer. This a equal to 1. The whole thing, the rest of the equation that you skip, you won't get the marks. Okay, so you get a equal to 1, and then b, do the partial fraction, you get 2. Okay, so substitute the value for a and b here, so you get 1 over 1 over 4 and then plus 2. Okay, so you get exact equal to this equation. So now let's see, we assume that you know that exact is actually equal to x1 plus x1z plus x2z, so which is this one lah. So you have x1, x1z, x12z, right? And where actually if you convert it to the inverse z transform is that you have xn value, so you can actually do this thing too, is that you convert x1z, you will get x1n, and x2z, you will get x2n. So the question was, okay, b was to get the partial fraction. So this is the answer for partial fraction. Okay, so later on we are going to use this part to actually answer for the region of conversion. Okay, for part C. So part C is that find the inverse Z transform Xn and sketch the region of conversion for the following. So for the first one is that you have Z more than 1 over 3. So Z more than 1 over 3, meaning that you are looking at this equation, right? 1 over 3. Okay, so if you look at 1 over 3, meaning that you're looking at x1n just now. Okay, look at this. You get the equation 1 over 1 minus 1 over 4 inverse z with the ROC, which is z more than alpha, z more than 1 over 4 for the first equation. For x2 is that you get 2 over 1 over 1 over 3 inverse z, and where you get the ROC is z more than 1 over 3, because just now you were taking for the equation z more than 1 over 3. Okay, so by inspection directly with the Z transform table, if you look at this, means that you are looking at this inverse Z transform, and you have alpha n un. So alpha n un, just directly match it. So xn you will get 1 over 4 n un, and x2 is that you get 2 1 over 3 n un. And finally, oh sorry, I missed this, xn, you get x1n plus x2n equal to 1 over x1 plus x2. Okay, finally you get this answer. Okay, for the ROC means that for the ROC, the region is actually more than 1 over 3 is over here. Means that it's going to overlap both. 1 over 4 is actually overlap both. So this is ROC for 1 over 3. So number 2 is that plot for Z less than 1 over 4. Okay, Z less than 1 over 4. So are we going to look at this one or this one? Of course, the second one, right? Which is less than alpha. Okay, so by doing that inspection is that you're going to get the Z transform here, and next is getting the inverse. You will get the inverse Z transform for xn. So let's look at how you get the answer. So first you are going to get x1. Okay, you are going to use the equation, this one, 1 over 1 minus alpha. Okay, so you will get 1 over 1 over 4 inverse z, where you have less than 1 over 4, and x2 you have 2 over 1 minus 1 over 3, which is less than 1 over 3. Okay, by inspection, if you see this one, you will get this equation as the xn value. So you will have minus alpha n. So you have minus alpha n u minus n minus 1. This is the equation, okay, for the case of less than alpha. So that's why our x1 value you get minus alpha. What is alpha? 1 over 4 n u minus n minus 1, and x2 you get minus 2 1 over 2 n u minus n minus 1. So you get xn is x1 plus x2. Final answer, you get this answer. Okay, so this one is for z less than 4. So z less than 4 is actually, if you take into account the both overlapping areas, so 1 over 4 is actually here, okay, 1 over 3 is where? It's actually here also, covering 1 over 4. So that's why for the region of convergence is we only take less than 1 over 4, means that the overlapping area. Okay, and for this case is that you see that the system is not stable. Why? Because it does not cover the unicircle one. Okay. Lastly, let's go to the last part, which is the region between 1 over 4 to 1 over 3. Okay, so if you see here that you have two. First part is z more than 1 over 4. So we are looking at this, okay, for the first part. Second one is we are looking at z less than 1 over 3. So second one is less than 1 over 3. So this one. So meaning that for this third region is that you are going to have the combination of these two equation for xn. Okay. So let's do that. So for x1, you have x1 for more than 1 over 4 is that you have the region more than alpha. So more than alpha means that you have the same equation for x1 z one value. Oh sorry, this one is z. Sorry. Okay. So xn, so you get z is this one. Okay. So you have x1 and x2. So by inspection, this is important in this part is that you need to look at the region. Okay, for region is, for this x1 is that is more than 1 over 4. So more than 1 over 4, which is this one, we are taking this. So you are going to use this equation. So that's why you have 1 over 4 and un. Okay, and for x2 is that the region is less than 1 over 3. So less than 1 over 3 is that you're going to look at this equation. So you have minus alpha. So you have minus 2, 1 over 3, and EU minus n minus 1. So finally, you have the n equation xn equal to x1 plus x2. So you get this equation as the final equation. Okay, and how to plot it is that you have z less than 1 over 4. Sorry, z more than 1 over 4. Z more than 1 over 4 is here. And z less than 1 over 3 is here. So means that you get the donut shape or ring type ROC. Okay. So this one is an exercise. So please do this as an exercise. I'm going to take this as a marks for quiz also. So you have two exercise, 1 and 2. So student need to submit this. I'm going to give you 1 week to submit it as usual. So the deadline will be next Wednesday. Okay, so submit it, and I'm going to give it mark as a quiz. Means that it's a take-home quiz. Okay, so write clearly how you answer it. Okay, write your name and so on, and submit through you learn. Okay, so you have two questions. So exercise 1 is you are given this equation, determine stability, obtain partial fraction, and find the inverse. Okay, and equation 2 also the same thing. Okay, find the differential equation of the LTI system. So for this case is that, okay, try to look at the table, Z transform table, rearrange this. Okay, you have yn, xn, right? So normally you have the input, okay, xn, yn, we have h, okay, the system equation. So h, z is y over x. Okay, so rearrange this so that you get this equation. Okay, here's z, y over x. And then next you can find, you can do the determine the impulse z of z, so this, which is this one lah, I gave you the answer. Then determine the stability, find the ROC, and give the reason why you think there's the stability. Then do the partial fraction and find out what is the inverse and sketch the ROC for all the following. Okay, so 2 exercise take home as a take home quiz, right? Individual. Alright, so that will be the end of chapter 5. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.